Yeah, thanks for the warm welcome. I'm very happy to be here. I want to start with a question, stimulate all of you after coffee break, and it's the afternoon after all, right? So who is already using internal platforms at work? Self-service platforms, developer platforms? Raise your hands. Okay. Follow-up question, again, to anybody in the room. Who considers themselves working for a large engineering organization? So multiple developer teams, kind of stuff. Okay, good news for those of you who haven't had the hands raised for both of these questions is that probably in 2 to 3 years, most of you will have their own internal platform. At least that is what Gartner says, because 80% of engineering organizations are trending towards establishing platform engineering teams in their organizations, are trending towards putting those platforms into place to enable their developers and engineers throughout the whole organization. And the question, of course, is why is that? Why do they see an uprise in this? Why do we have co-located platform cons with KubeCon and they're sold out every year and stuff like that's happening? Before I dive deeper into this, I want to introduce myself real quickly. I'm Daniel Bodky. I'm a platform advocate at NetWays Web Services from Germany. We offer managed Kubernetes, managed databases. Basically, many of the things you might want to run as infrastructure, we can manage for you. I'm an ex-systems engineer and consultant on many things cloud native. Before that, also a bit of observability. So what Dotan just talked about really hit home. And these days I focus on Kubernetes, platforms, and GitOps mostly. You can reach me on, most of the social media is relevant in tech. Reach out after the talk on the hallway track as well. And let's get right to it. So what is a platform? Is it some product I buy off the shelf? This is not a joke, by the way. Spotify just launched their own product, like their own platform offering, which you can buy now off the shelf. There are, of course, other vendors as well. Is it something I built myself, where I just throw all the stuff into it, right? Call it a platform. If I'm lucky, I get some unified API out of it. Or is it something like this, basically documentation, living in Notion or Confluence, just pointing people to the right places? Well, of course, this is trying to catch you off guard because it can be any of these, right? Everything that works for your organization and for your teams can be considered a platform of some kind. So how do I get there? Why would I want that? And how does the CNCF define platforms? So that looks a bit like this. A platform is an integrated collection of capabilities defined and presented according to the needs of the platform users. And two things that are very important to notice here and to note down is it needs to be an integrated collection of capabilities. So one tool, no matter how good it is, can hardly fit any use case, every use case. So it needs to be a collection of capabilities of your organization. It needs to be unified in one place so it's easy to find. And at least after some time, it needs to cater to the needs of the platform users. And that means, in the best case, all of them, right? Everybody should reap the benefits of a platform. And it's not the perfect paradise of your platform engineers what they want to build, it's what they need to build to enable their engineering teams. And in other words, let's summarize this and keep in mind for what's to come throughout the talk. Platforms need to help solve common challenges throughout your organization, provide golden paths for processes within your organization, establish a consistent look and feel for multiple technologies. That's also connected to what Dotan said earlier, where he sees a trend of engineering organization platform teams streamlining this metadata definition and collection. What do I need to collect where for their engineers so they don't have this extra cognitive load to deal with, right? They need to cater to a variety of autonomous teams these days more than ever with data sciences, MLOps, everything at once coming together and needing infrastructure, needing code, needing pipelines. And I want to stress it again, you need to do this throughout your engineering organization as a whole. So that sounds like a whole lot of work, right? Why would you want a platform like that? Why would you go out and about and build this? Well, do you remember DevOps? We heard earlier in the Ignite talk, it's a bit older by now, at least 10 years, I think 15th birthday this year coming up. It looked a bit like this, right? There were walls in there. There were dev teams, then they threw code over a fence is what I heard quite often, and QA had to figure out what to do with this code. And then they again threw code over a wall or a fence to ops, and they had to figure out how to run it, how to maintain it, how to debug it, how to troubleshoot it. And the solution was just tear down those walls, right? Let people talk to each other, unify tooling, make them work together, make them collaborate on their projects, and get those pipelines flowing without the walls in between. And in my eyes, at least, platform engineering can be quite similar from a certain point of view, because once again, we have those teams with different needs, which aren't so different if you look at them closely. So, for example, we have backend teams, and they need some kind of relational database and message queues, and maybe some pipelines, of course, to build their projects and verify everything's working, right? Then we got front-end teams, and maybe they need some fancy CDNs to cache their stuff at the edge close to their users, or they also need pipelines, and maybe they need some kind of object databases or stuff like that. And then these days, especially, we got data scientists, ML ops, data engineers, and they again might need vector databases, whatever. I'm not the most proficient guy in those areas, but again, we have teams with different needs, and naturally, those differ, right? It depends on what you're working on, what you're working with. So how would I go about building a platform for them? Well, the first step would be to look for similarities. So all of them need different databases, all of them need some pipelines in some kind of ways, message queues and so on. So why not bring all those teams together and just at least establish a common point together and to get your stuff, right? That already makes it easier. If you have one centralized place to go to, then you have one centralized place where every junior engineer throughout your organization after 2 weeks knows where to find the documentation, where to find golden paths, where to ask for help, open tickets, get in talks with the platform team themselves. And this is the starting point. Empathize with your teams, start with 1 or 2 in specific use cases, and work it out from there. And that's because platforms can really help your engineering teams. So the Gartner report says they were able to observe improved productivity and efficiency through, for example, self-services. They had the teams with platforms at their hands had reduced operational overhead because lots of cognitive load got taken off their shoulders, right? The junior engineer didn't have to ask the senior engineer, what are the parameters I need to put into my Go build pipeline, right? The build flags and stuff. It's all there in the best case. The repository gets bootstrapped for you with all the pipelines you might or might not want to run. You get faster time to markets for products and features and patches as a result of that, because lots of everyday processes and cognitive load gets streamlined and automated for you. And you get consistency and standards across your organization. And for me, this is the most important one. This also goes, again, in the direction Dotan was talking about. You need to put standards into place to make sense of data these days. It just gets too much. And if every microservice follows a different design concept, follows a different way of emitting logs and metrics, traces, whatnot, it gets very hard to deal with at scale. And all of that might bring you from why would I build a platform to how do I build a platform? And this is where it gets very interesting, because it's quite easy. I hope all of you brought your magnifying glasses and got your favorite colors, because you just get to pick your most favorite logos up here now, smash them together, boom, there's your platform. Day 1 already operational, right? Unfortunately, that doesn't work because, and this is already taken from the Kunos projects website, which I promised would be the main topic of the talk, internal developer platforms are a strategic commitment. Share learnings and build in the open is thus kind of mandatory these days. There's just too many offerings available otherwise. So what does that mean? Of course you can't, let me go back, take any of those, right? Some of them don't work so well together, even though they coexist on the cloud-native landscape, which this is, by the way. But some don't, and there are golden paths. Some are better maintained than others, have shorter reaction times from the maintainers, are easier patchable, stuff like that. So building platforms, making sense of all those offerings and putting together those bits and pieces that might make sense for you is highly strategic. And that's why there's a framework, the Kuno framework, Cloud Native Operational Excellence framework, which is a collaboration of quite big companies. From the top of my mind, I think AWS is a member, Adobe is a member, Nike is a member. A few other companies are founding members of this framework, this endeavor. And it's main purpose is to bring enterprises, big enterprises who have need for platforms like this together and talk about operational technology decisions. Which GitOps engine do I use? Which one goes well with all the other tooling in my stack? Which tooling should I use at all, or maybe not, because it might not survive the next 2 years due to, I don't know, missing funding, or which tooling do we need to fund further so that it will continue existing and we can build our platform on top of it or make it a part of our platform. To coordinate contributions, right? All big companies these days contribute to open source projects. That's not anything super special anymore, I think, but you still need to make the decision which projects your engineers should invest their time into, right? And it offers guidance on available technologies for all other companies who want to build platforms. And the Kuno project and framework is built on a few tenets, 6 in fact, and I listed them here shortly. It's open source first, so when there are open source solutions available, those get prioritized because it's easier for you to patch them, to fork them if needed, to contribute upstream, to pay it back or pay it forward. The second one is it's community driven, so the decisions on technologies, on the suggestions they will publish over the time, and the contributions they will drive are driven by the community and its governing body. It's about tools and not practices, which is quite the opposite of DevOps, which is like a culture, or as we heard, a result. So it is in fact about this tool goes well with that tool, or not, and not this practice goes well with that practice, because practice has to do with culture, and culture is intrinsic to each engineering organization on its own, right? Engineering organizations differ, and you still need to find practices which work for your organization on top of tooling that is pretty much standardized. The fourth one then is that it's powered by but not limited to Kubernetes, which basically means these days with the CNCF as the backing organization and all those, this whole ecosystem pretty much flourishing, there's so much tooling available which is built on top of Kubernetes, utilizes its APIs and so on, that it makes sense to build your platform on top of Kubernetes. It doesn't mean that it's limited to managing and orchestrating Kubernetes, right? I brought a demo for you for later. I will actually deploy stuff on AWS and on our own cloud offering from the platform I built on top of Kubernetes. The fifth one then is that it's standardized infrastructure customizable by users, which basically means something along the lines of it should be easy to use the platform and to get started, but you are still enabled to do all the tweaks and little things you might want to add, like custom patches, hook your own API in there and stuff like that. And the last one is the Kuno project and everything it builds is meant to be shared. So all the developments, all the white papers, all the reference architectures, which I'm going to demo in a bit, are publicly available, are open source, and you can consume them as you like. And with this, we get to the idpbuilder CLI, which is the second thing I want to present today, which is the more practical part of my talk, which is a command line tool for bootstrapping, extending, and developing an internal developer portal based on the reference architecture authored by the Kuno project. You can see the Instagram, yeah, nice try. The GitHub page here. It's not that popular yet. It's still very hacky. But it works, and I will show that in a bit. But first, what do I get from using it? When I deploy the reference architecture of the idpbuilder implementation, I get a few core packages. I get ArgoCD as, why is the color so off? I don't know. I get ArgoCD as the GitOps engine. I get Git, which is a lightweight source control management system written in Go. Just very basic set of features, but works incredibly well for GitOps because it's so lightweight. On top of Kubernetes, it installs Backstage. Probably everyone in here heard about Backstage, or most of you, and all the memes it entails. Like, if you do Backstage, even though it's completely empty, you're a super good platform engineer, right? You do platform engineering because it is the platform engineering front end developed by Spotify and open sourced shortly after. And you get a few other things. You get Crossplane, which is a cloud native control plane framework. This will enable us to basically orchestrate anything we can think of from our platform based on Kubernetes. We get Keycloak, which is an IAM platform. So we get authorization and authentication from day one, which is pretty neat, even locally, because you get the real feel for things, even when you're just tinkering with it. And for secrets management, it also installs the external secrets operator. If you haven't heard of some of those tools, don't worry. I will dive into the demo right away and showcase all of that a bit. So you definitely haven't have to have an opinion about all of those. So let's switch over to my terminal first. I already ran the idpbuilder bootstrapping command, and that is because it takes some 10 minutes or so to get everything up and running. But what we end up with is this. And I can maybe, is this readable like this? Perfect. So we get basically all the stuff I was just talking about, a few applications which make up our platform. And those are also available locally on those addresses. And let's have a look at what idpbuilder did for us. I first need to fetch the secrets. Let's start with the ArgoCD secret. I can switch to my browser and log in. And we see a few applications. Applications in ArgoCD are workloads managed in a GitOps way by ArgoCD. And we see basically all the components I was already talking about, right? ArgoCD is managing itself. There is Crossplane. There is some core cluster services. We get Git here, external secrets. So basically everything, even though we bootstrapped it with idpbuilder, is now managed via GitOps. How does that work? For this, we can take a look at the idpbuilder repository and its ref implementation, which is not here anymore. What? Where's the folder? Okay, no problem. I will show locally then. So what I deployed was everything in here. And we can see that's, of course, again, lots of YAML, which you can put into version control. That's not so bad. But the entry points are the interesting things, because for each application idpbuilder bootstrap for us, there's one directory and there's a top-level YAML file. And if we have a look at those top-level YAML files, for example, the Keycloak one, we can see that it's basically a pretty common off-the-shelf ArgoCD application CRD with one interesting thing, which is this source referencing some CNOE protocol path, which makes no sense intuitively. What actually happens behind the scenes is that the idpbuilder CLI parses that, then takes the relative path, which is Keycloak manifests, and puts all of that in a Git repo in the deployed Git instance. So we can do GitOps after the platform has been deployed. We are not locked in with idpbuilder forever managing our evolving platforms, right? It bootstraps it and then hands off control to us via GitOps and Git running in cluster. We could, of course, migrate all of this to GitHub Enterprise or whatever floats your boat. But just to get a look at the state in Git, let's get the secrets for Git. No, come on, like this. And we can see there's 11 repositories, right? And they're all prefixed with idpbuilder local dev, which means that this repository was created by idpbuilder in the cluster local dev. And there's basically one for each application. So there should be Keycloak here. And in here we find all the manifests which were referenced with this funky CNOE relative path. So that's it about setting everything up with idpbuilder. Let's have a look at what we get from this reference implementation. For that, I will log in at Backstage, which also showcases Keycloak. And we see we got no components, but we get 2 locations and 3 templates. Locations are basically ways to reference Backstage where our component templates are residing. and our templates is what it makes out of them, what it parses. And those templates are what we are offered here when we say create a new component. And out of the box, we get these three templates. And I want to start with the AWS resource because I was claiming that the CNOE initiative and the IDPbuilder reference implementation builds on Kubernetes, but is not limited to Kubernetes. So let's deploy something else. Let's deploy an application with a bucket. So we choose object storage here. It's already the default. I just need to set a region. I go and review. And we can see adds a Go application with AWS resources. So what I expected to get me is a standardized, bootstrapped repository where I can start developing a Golang application, and a bucket which I can use for developing or staging and testing purposes. I click on create. Backstage runs the pipelines. Those run in Argo workflows. I forgot adding that to my slides, so it runs in cluster as well. And let's have a look, because in Git, we should now see that there's a new repository because we want to do GitOps again, right? Everything should reside in Git. The state of our workloads gets, the desired state gets saved to Git. And what we see here is, indeed, we get a Go mod, which actually even shares the name, so that gets templated for us out of the box. We get main.go. Apparently, our platform engineering team wants us to use Go 1.19. And we also get the catalog info, which is the way for Backstage to know what's inside. So it can go on and keep track of what we have in store, what we have to offer, the microservices we are developing within our engineering organization, stuff like that. And we also get a customized directory with the demo bucket app.yaml. And this, in turn, is a Crossplane CRD. And let's switch to AWS and see if this actually works. So if I refresh here, we can see that almost in real time, there was a minute or so, I got my bucket in AWS. And with some more work and not just the IDPbuilder bootstrapping everything, I could put this in the right billing project, and I could give access to my developers or the person who requested it, right? And it's just there. Let's have a look at what this looks like in Backstage. We get this new component demo bucket app. We get quick links back to ArgoCD, so I can look at the GitOps state of things here. It's all synced up, perfect. We see the dependencies, so this component depends on the resource, which is the actual bucket residing in AWS, and so on. This is a neat little toy thingy if you want to get a feeling for different CNCF projects, but how do I start building it out? Where do I go from here? Well, IDPbuilder cannot just bootstrap the reference implementation. It can take arbitrary projects of the same structure and add them on top of this. So I can build out my platform step by step. And if it's good, I can do it in a more production-like way with, for example, the deployment tooling I normally use in my organization. I prepared another template for Backstage, which is in this folder. It's called NWS Crossplane. NWS is our managed service offering and platform. And yeah, Crossplane allows us to talk to it via the OpenStack provider because our cloud is built on top of OpenStack. So what we got in here is, again, a top-level YAML file with the ominous CNOE path, and then a few things Backstage needs under the hood. So if I go ahead now and say idpbuilder create, this is just the flag I need for my local configuration, and reference this one, IDPbuilder starts running. Basically, IDPbuilder are two Kubernetes controllers in a trench code running outside your cluster, talking to the cluster via your kubeconfig. So they reconcile a few things and shut down afterwards. What we see now is that in Git, we get another repository because IDPbuilder read the CNOE reference and created and ported all those resources into a Git repo, so I can do GitOps again. And if I now take this catalog info and point Backstage at it, this is basically importing the template. I now get the new service I just imported into my cluster, the new self-service offering I want to offer my platform users, for example, which is create a Hugo website. And it creates a repository for a new Hugo website and a VM to deploy it to, right? So I can test if everything works as I think it should. And I will call this one NVS Hugo. I can choose a VM flavor. Oh, that is nice. I expect lots of traffic, so I take a medium-sized, but for some weird reason, I want to go with Debian 10 instead of 11. I think 12 is the most recent one, right? Okay. Click on Create. And again, after a few moments, by now, maybe you got onto how all of this works. We can take a look at Gitty. We should see another repository. Indeed, everybody who's written a Hugo blog before a Hugo page, we get all the repositories we would expect from like a Hugo scaffolded project with the catalog info for Backstage and the customized folder where the Kubernetes related resources live inside. Those we can find in ArgoCD again. Right now it's reconciling. Oh no, that's the other application. Right now it is synced already. Okay, perfect. And this means that on the platform, this is the NWS cloud platform, I should now see that, ta-da, it's not AWS, not a hyperscaler, but my solution where I wrote the Backstage platform template for works as well. And all of that was half an hour of writing a YAML manifest and then deploying it to the cluster using idpbuilder. And I think that's pretty neat for just trying out, building out your offering using battle-proven CNCF projects that go well together. And with this, I think we came to the point where I can sum it up. And that's the 4 points I want you to take away. Platforms can enable standardized streamlined processes, which means, as we already saw, you can enforce that certain tags need to be set. So I left them open because I didn't want to waste time on them, but I could have made those fields required, and I could validate those fields before allowing them to create AWS resources or deploy resources to Kubernetes. I could enforce certain metadata to be added as labels and annotations. I could enforce certain sizes of workloads so that my engineers don't always take the 2XL EC2 instances so they don't need to troubleshoot resource usage and stuff. Building platforms then is about empathy with your teams. So at the end of the day, I stressed that a few times. I think you guys are quite sick of it by now, but your platform needs to cater to, in best of cases, to your whole engineering organization. And this also means that it's totally fine to start out with one team because you need to find people within your organization to fight for your cause. For the people with a budget in hands, a platform just costs money in the beginning, right? It's effort and it's engineering hours that go into it. So you need to prove a point. You need to tell them, to show them it works. People get value back out of it. And that's best done by listening to your teams, finding a use case they're struggling with and solving it for them. Building the first offering on top of your platform. And yeah, maybe the Kuno project can help you with making the right choices or getting inspired how to build out your platform. And more precisely, idpbuilder can then help you build MVPs or just try stuff out locally before even evaluating it for your company in a very quick and easy to set up way. That's it. Thank you. Those links are basically all the footnotes I had throughout my slides. You get to the slides by scanning the QR code or at this link here in the bottom. Thanks for listening. And I'm open to questions, of course.
Thank you very much. Are there any questions?
So to me, it looks like, okay, you have a chosen set of tools. What if I want to use another tool or something like that to integrate it? Is it possible to, I don't know, use some other Git platform or something like that instead of Git, for just as an example? Is it extensible, or do you say, no, this is actually, the good thing about it, you can install it and it's perfectly integrated within each other.
It's totally extensible. So you can do all sorts of stuff with it. As I showed the GitHub page of the project, you might have seen it's quite new. It's still quite small. It's getting more and more traction and people on the Slack channels and so on every day, but it's growing slowly. But there is more of those packages, like the ref implementation I demoed and the one I added afterwards, which I wrote myself, which are getting added in the official example repositories. And it's totally possible to point your GitOps engine, whatever that might be. Also, that's not set in stone that it must be ArgoCD, but for now it is. To something different than Git. Git is just the easiest way to get started, especially when you try stuff out locally. So I still remember when I started out with GitOps and trying out things, I didn't have like a Git or something running locally. So I really always had to start up new GitHub repositories. Then I had the choice, do I make them public? And my profile looks like garbage with 250 abandoned repositories. Or do I make all of them private, but then need to track paths and need to tell ArgoCD, the paths and stuff like that. And Git makes this quite easy because it runs in cluster. It's also not accessible except for the ingress, which is running locally, right? So this is just the easiest way to get this whole life cycle started. But you could take all those repositories within Git, move them to your GitHub Enterprise with the official export-import functions, which exist for both solutions, and tell your GitOps engine that they reside there now. And I think with time, there will also be a possibility to bootstrap idpbuilder within, for example, your GitHub organization from the start, so you don't have to take this way of using Git. But that's just really the way of least resistance to get started, and that's why it was chosen. It could have also been GitLab, but that's like a different monster, right? And even inside your cluster.
Okay, thank you.
Are there further questions? Oh, yes, you have to throw here.
Well, there.
No.
Thanks. Thanks, Daniel. Very, very good talk. I have a small question about the CNOE project. Is it like a bootstrap thing only, or does it like also have like the two operation with updates? Because once you migrated away from Git and you make an upgrade, will you then get a new Git or like?
That's a good question.
Keycloak updates and so on and so on.
Sorry. That's a very good question. As of now, it is like that. So if I migrate them away, and I tried that, it all works. It's like as straightforward as I just said, and as you might think it is. But if you then import another one of those building blocks, maybe you wrote it yourself, maybe you got it from the other example repositories of the project, yeah, it again ends up in Git, and you need to move it out of there. That's just like where the project is right now, and I imagine it will evolve further, and then you can move the stuff around where you want it to be, where you need it to be, out of the box. Okay, maybe I misunderstood your question. Do you mean updated as in just when applications within the project need updates, or yeah? I actually don't know. So right now the releases come quite often, and they just bump the versions. But it is a bootstrapping tool, yeah. Which is fine, because afterwards, the idpbuilder CLI, even when applying new stuff, they don't touch the existing repositories. So if you and everything is in GitOps, as I showed in the beginning of the demo. So if you need to bump the versions, just bump them in version control, and you update it, basically, yeah. But the CLI doesn't do that for you. It's basically a bootstrapping and extending tool, yeah. No lifecycle management.
Okay, there was one.
Yes,
so
in the back.
idpbuilder as a tool is a collection of a lot of other tools. Which one do you think is the most mighty one? Which is your favorite?
Oh, my favorite. So just to be a bit nitpicky, idpbuilder is like just the CLI which happens to install those tools. It's not per se a collection of those tools, but because it could basically install anything, it's more of a process of installing things looking a certain way. But yeah, my favorite tool is probably ArgoCD, because back in the days when I was still consulting, it was very easy to get started with. It's very straightforward with its UI, but you can still do really powerful orchestrated multi-cluster GitOps day 2 operations with it, with the advanced features it has. And yeah, as I said, it has a UI, so you don't even need to build a platform around it. It is like a miniature platform in itself if all you need to do is GitOps. If you need more, then you need to start building around it, right? But also in this demo, it was at the heart of things. So everything was consumed by ArgoCD, and then stuff happened, right?
Thank you.
Any more questions? Otherwise, I'll still be around for the rest of the day and tonight, of course.
Thanks for the great talk, and thanks for mentioning the CNCF white paper as a CNCF ambassador. And one note for those who are interested in, there's another white paper that is the platform maturity model. So if you are not about the tool stack, but more on the practices, if you want to look into that, also a very interesting work by the TAG app delivery, the technical advisory group for app delivery. So
this one, really, really good one. Yeah, Dotan is completely right.
And the credits go to the tag app delivery maintainers.
This one helps you to define how mature your platform, or where you are on your way to building your own IDP for those 5 key points.
And more interestingly is what's the next steps that you need to take. So if once you map where you are, makes it very clear what the next steps are and where you want to put your efforts and focus to get to the next level, if it's relevant for you, obviously.
Yes. Okay, then thanks again. It was great being here. See you later.